course. That's what we're doing this whole entire chapter, right? By matrices. Yes, more than one matrix. Great question. I'm so glad you asked. A matrix in math is a box full of elements, so to speak. I have this box, and in here I have elements. The first one is A, and this is called 1, 1. Okay, the first spot. The second one, if I had a second row, would be A, 1, 2. Third one would be A, 1, 3. Then the next one would be A, 2, 1. A, 2, 2. A, 2, 3. Okay? And if I happen to have one more row in here, that would be A, 3, 1. A, 3, 2. And A, 3, 3. These matrices can be of any size by element. All right? What these numbers mean at the bottom is it is the element. This is called an element. The number at the bottom is row by column. All right? So if you look at this, for example, this is row 2, column 1. Right? Or if I want this one, this is row 1, column 3. Okay? So, why is this important? Well, example number 1. Find the element. If I give you this beautiful matrix, let's say I have 1, 3, negative 2, 7, 4, 9, 5, negative 5, negative 1. All right, and I want you to tell me what is A22. It is, exactly. What if I said I wanted A31? Okay, what if I said I wanted A13? Good. All right, that's not hard at all, right? We're still good? That's the first 2 questions in your homework, though. That's okay. You just have to go to wherever the element is they're asking for and name it. Okay? So even if you got, for example, you could get a matrix that is 1, 3, 3, 1. And if I said, what is A21? What is A21? This is row 2, column 1. It would be 3. Okay? All right, so it doesn't matter. You just got to go to where the element is. All right? Other questions before I keep going? Okay. Matrices, or a matrix, can represent a system by what we call a coefficient. It's supposed to be an O, by the way. Doesn't look like it, but it's supposed to be. Coefficient matrix. So, if you are given the matrix or the system, let's say 3x plus 4y equals 2, and negative x plus 7y equals 5. We can take those coefficients in the numbers and put it into a matrix. All right, so the coefficient matrix for this would be 3, 4, 2. Second line would be negative 1, 7, 5. You're literally just taking the numbers and taking out the variables. That's all it is. It is easy enough. Okay? So I do want to tell you that sometimes this book tends to put like a dash line down this just to separate it as like an equals from the coefficient ones. Just so you realize that's what this book does. Now next year your pre-calc book doesn't do that. So it just depends on the book. They sometimes include that line in there to say it's separating it from the equation and the answer. Okay? All right. So here's example number 2. This would be the next section in your homework, what you have to do. You're going to be given a matrix, or a system, excuse me, that's maybe 3x plus 4y minus 2z equals 4. X plus y equals 3. And 2x minus 9y plus 3z equals 1. Write the coefficient matrix. Okay? So you're going to put your little bracket. First equation, the coefficients are 3, 4, negative 2, and it's equal to, if you want to think about that dash line, 4. Now these have to line up. So the first column, of course, is our x's. Second column, of course, is our y's. Third column is our z's, right? So when I write the next one, I have 1x plus 1y. How many z's do I have? 0. Make sure you include that 0 in there. And it equals 3. Last equation. 2, negative 9, 3, and 1. That's it. Okay? Still doing well? Annika. It's up to you. It doesn't matter either way. It's just whether it makes you feel better, it gives you a better understanding of what's going on. It's totally up to you. Yes, ma'am. No, definitely not an equal sign. Okay? All right. So then example number 3, we can also go the other direction. So if I gave you a matrix of 1, 2, 3, and negative 4, 5, 1, and maybe I put a little dash here to help you, I want you to write the system. Maybe. It'd be x and y. You always start with x and y when there's only 2. When you go to 3, it's x, y, z. When we go to 4, it's x, y, z, w. So, I know it sounds weird, but, okay? Just 'cause. So when we write this system, remember these are our x's and these are our y's. So we're going to start with 1x plus 2y equals 3. Next equation. Negative 4x plus 5y equals 1. This is easy. We're doing okay? All right. What? What was the title of this section? All right. I know. You guys are going to be fine. So, we are going to talk about solving a system using matrix. Nope. Not yet. Because you had to understand how to write it in that form and what it meant, right? Yes. Okay. So here's the one thing I want to tell you. When we get to the solution in your calculator, okay, this is what the solution will look like. It will always have ones in the diagonal, zeros everywhere else, and then your answer in the very last column. So think about what I just wrote. What that means is that x equals 2 and y equals 3, right? Or you can write it as 2, 3 as our point. Kind of, but, okay? So when we get to the answer, that's what it's going to look like. So for example, if when we get to the answer, I'm going to have 1s in the diagonal, 0s everywhere else, okay? And then maybe I have 3, 4, and 5. So in this one, tell me what equals 3? X equals 3. What equals 4? And of course, then what would be 5? Good, okay. And again, you'd write it as 3, 4, 5 is your solution, right? So now we get to learn how to use the calculator to find the answer for our matrices. Okay? This form of the matrix, just wait, just a minute. Okay. This form of the matrix always follows this RREF. Okay? What this is called is reduced row echelon. That's what it stands for. All right? I know it's a big word. You're not going to learn how to do it by hand until next year. Your calculator is going to do it for you now. All right? Once you learn how to do this, you can use this on the SAT. You can actually solve systems by plugging it into a matrix in your calculator. Okay? So, here's what we're going to do. Example 4. Solve. And we are going to begin by solving. Now I'm going to give it to you in matrix form, of course. Let's go 1, 1, 5, and negative 2, 4, 8. All right, so I want to show you how to plug this in. This is what we've got to learn how to do. Okay? So the first thing you're going to do is grab your graphing calculator, of course. I need you to go into, if you see above the X with a little -1 there, underneath math, there's a blue matrix word. You see that? Hit your second button in matrix. No, are you going to listen? Push over to math, and you're going to scroll down to RREF. You want me to put it on the one up here? Okay, hold on. Relax. Hold on. No, not yet. Hold on. Yeah, no kidding. Hold on, guys. Let me get everything so I can talk to you through it. Once we get it, it's going to be super easy, okay? So, the very first thing you have to do, again, once it loads. Come on. Come on. All right. So let me get out of what I got going on here. Maybe, if it'll let me move. Okay. So, first thing I said, that you want to go to this blue matrix. So I hit the second matrix button, right? I need you to push to the side so you can go to math. Okay? We're all still good? And then you're going to scroll down till you get to what I just said, which was RREF. Now go ahead and hit enter. So on your screen you should have RREF. Okay. Now we have to put our matrix in. Are you ready? What's wrong? Go ahead, Allie, you had a question? I want RREF. That's the next one. Okay, to get to where our matrices are, okay, you're going to hit the green alpha button and this zoom for the F3. Okay? Everybody good? It comes up this way, right? Okay. So the matrix we just wrote is how many columns? right? It was 2 columns. Or sorry, 2 rows, my bad. 2 rows and 3 columns. So that's what you need to go to here. My rows are good, but my columns need to go down, right? Yeah. What doesn't pop up for you? Okay, well, just give me a second. I'll come check it, okay? Okay. So, did everybody get to this screen except for Matthias? You need to go to 2 rows, 3 columns, and then go down to OK and hit Enter. It comes up with those 3. We are now going to enter the numbers into that. So we're going to put in a 1 for the first one, push to the side, another 1, push to the side, and then a 5, right? Okay, the next row, we are putting in -2, second one was a 4, yep, and then you get an 8. Okay, and I'm going to hit Enter. We get 102,013. So tell me, what does X equal? What does Y equal? Beautiful. Okay? So we're going to try another one together. Are you ready? So I'm going to shrink this down for a second. We're going to go back. We go back to here. Oh, not back to there. Sorry. Back to here, as I'm trying to do a lot of different stuff. All right. So example number 5. Again, I want you to solve. But this time, we're going to start with the system. Okay, so have everybody's attention? We're going to start with the system. X minus Y plus Z equals 0. Or no, equals 3. Excuse me, equals 3. Second one, we have X plus 3Z equals 6. And the third equation we have is Y minus 2Z equals -1. So the first thing we have to do is change this into our coefficient matrix, right? Before we can put it in our calculator. So our coefficients across the top are 1, -1, 1, and 3. Second row is 1, 0, 3, and 6. Last row is 0, because there's no x's, 1y, -2z equals -1. All right, so this time, again, we're going to go back into our calculator. We're going to practice this again. You're going into matrix, over to math, going to push down to RRES, and hit enter. You have to have that RREF there first. Then we're going to go to alpha, F3. This is a 3-row by 4-column matrix. Rows are this way. This is rows. Columns go up and down. Like a column on a building or whatever. Yeah. 1, 2, 3, 4. Right? Okay. So I want everybody to get that in there. And you're going to enter the numbers. And you're going to hit enter. Okay? All right. So I'm going to set this stuff down for a second. I'm going to walk around to see if I can help anybody with your questions. Okay? All right. I want to make sure everybody's getting this. You should get for an answer when you do it. You should get an answer of, yes, 3, 1, 1. Okay? And that went a little bit faster than how we solved it longhand yesterday. A little bit, right? Okay.